Okay. Good morning, everyone. My name is Chandan Kumar Gupta. I'm a Prime Minister Research Fellow in Department of Mathematics, IIT Patna. I'm your PMRF NPTEL TA for the course Probability and Statistics. This course is offered by Professor Somesh Kumar sir. He is a faculty in IIT Kharagpur. This is the extra session for the 12-week course. Okay. And in this course, today we have just discussed about some more numericals on the problem testing of hypothesis. Okay. Okay, so like the question is like a random sample of 1,000 people in Maharashtra (540) are rice eater. And the rest are wheat eater. Can we assume that both rice and wheat are equally popular? Equally popular in this state at 1% level of significance. Okay, so our question is like we are given 540 are rice eater and the rest, that is 460, are wheat eater. We need to test whether the rice and wheat eater are equally likely or equally popular at 1% level of significance. Okay, so let's solve this question. Like here we are given sample size is 1000, that is n equal to 1000, and let x be the number of rice eaters. Which is given 540. Okay, and now we need to find the proportion. So let us define P, which is the sample proportion of rice eater. Rice eater, which is x upon n, 540 upon 1000. So from here, the proportion comes out to be 0.54. Okay. Now we need to check. So now population proportion of rice eater is what? Since it is given equally popular, that is both are equally probable, that is both have a proportion 0.5. Okay. So we need to test like now population proportion of rice eater in state is Since it is equally likely, so the population proportion is 0.5. Okay, which we say that P naught, for example. Or okay, now the hypothesis are the first step is define hypothesis. That means both rice and wheat are equally popular. Both rice and wheat are equally popular, or we can write it like this. That is P naught equal to 0.5. Okay. And it's P equal to, for general notation, will let me write as P, which is equal to P naught for a given value against the alternative hypothesis. And the alternative hypothesis is either it is equal or it is not equal. Okay. Now the test statistics. The second step is test statistics. So in this case, the test statistics will be Z, which is P minus P naught, P naught, Q naught divided by N. P is given 0.54, P naught is 0.50, P naught is 0.5, Q naught is 1 minus P naught, which also 0.5, and N is given 1000. Okay, so from here it is 0.04, and in denominator it comes out to be like 0.5, and in numerator it's 10 root 10. Root 1 denominator 1000, it comes in numerator 10 root 10. Okay, and 0.5 into 0.5, it comes out to be 0.5. Okay, so this is 0.4 root 10, 0.5. After solving these, like we will get z equal to 2.528. Okay, so our calculated z is this. Now we are given alpha at 1% level of significance, that is 0.01. So since it is not equal to case, that is two-tailed case, so like alpha by 2 is 0.005. Now z 0.005 is actually 2.578. Okay, and here we find out like z is less than z 0.005. That is, calculated value is less than the tabulated value. Okay, so that means we fail to reject the null hypothesis. That is, we fail to reject. That is, we accept the null hypothesis. This means what? Like our question is, right and V's are equally popular. So yes, we accept it. We are failed to reject. That means we accept it. So we conclude that. Thus, we conclude that both rice and wheat are equally popular in this state. Okay, so on the basis of the information, we have concluded rice and wheat are equally popular in the state. Okay. Like a similar question. It is given a random sample of 400 men and 600 women were asked. Random samples of 400 men and 600 women were asked whether they would like to have flyover, whether sorry, whether they would like to have flyover near their residence. Okay. So we get the information like 200 men and 325, 200 men and 325 women were in favor of the proposal. Okay. Now test the hypothesis that the proportion of men and women in favor of the proposal are same. Test the hypothesis that the proportion of men and women in favor of proposal are same. Against that, they are not. Against that, they are not. Okay. At 5% level of significance. Okay. So we need to test this. Arya, I think you should mute yourself, or if you want to ask anything, then please ask.
Sorry, sir. Sorry, sir.
Okay. Okay. Now here it is given we need to check same against they are not. Okay. And we are given two sample problem here. So we are given 400 men and 600 women. Okay. So like N1, which is number of men, that it is 400, and X1, the number of men in favor of proposal. Okay. So that is 200. Number of men in favor, which is 200. Similarly, number of women and X2 number of women in favor, which is 325. Okay. And now we need to frame our hypothesis. So the hypothesis is same against not same. So that means our hypothesis is let P1 equal to P2 versus P1 not equal to P2. Okay, P1 proportion of male, P2 or women. Okay, so we need to check whether P1 equal to P2 or P1 not equal to P2. Okay. So what is P1 or P1 here is like x1 upon n1, which is 200 upon 400, which is 0.5. P2 x2 upon n2, 325 upon 600, which comes out to be like 0.541. Okay, so we have framed our hypothesis. Now the next step is to calculate the test statistic. So test statistic is z equal to P1 minus P2 P cap minus P cap multiplied by n1 n2 upon n1 plus n2. Okay, so this is our formula or z statistic. Okay, here P cap or P is what? P bar or what you say. Okay, so it is our combined proportion. So that means x1 plus x2 upon n1 plus n2. Okay, so that means 200 plus 325 upon 400 plus 600. So it is 525, 1000. It comes out to be 0.525. Okay, so 1 minus P, it comes out to be 1 minus 0.525, which comes out to be 0.475. Yes. Now the statistic is P1. P1 is 0.5, 0.541. Okay. So it is 0.5 minus 0.541. It is in under root and it is 0.525. It is 0.475. And then multiplied by n1. N1 is 400. 400 into 600 upon 1000. Okay, so just a calculation, nothing else. And here you see, like it is minus 0.041 upon this quantity, which after solving we will get like 0.4993. And here it is like 30 will be cancel out, 240. So under root 240, which comes out to be around 15.49. Okay, please use your calculator as well if any mistakes are there. So overall, after solving, we have found out like it comes out to be minus 1.2721. Okay, so that means modulus of z is 1.2721. Okay, and again, since it is not equal to case, and we need to test at level of significance. Okay, so z at 0.025, which is alpha by 2. This value is 1.96. Okay, now here we see that the z value is less than z 0.025. That is, calculated value is less than tabulated value. Okay, so in this scenario, we accept or we fail to reject the null hypothesis. That is, we fail to reject the null hypothesis. Okay, so we fail to reject the null hypothesis. And what is our null hypothesis? That P1 equal to P2. And that means we accept it. So we say that like the proportion of men and women do not differ. Okay, that means they both wants the same, like they wants flyover. Okay, you are in favor of flyover. Okay, so this is how we will discuss. The next question is like, a random sample of 27 pair of observation a random sample of 27 pairs of observation from a normal population gives a correlation coefficient of 0.42. It is likely that variable in population are uncorrelated. Variables in population are uncorrelated. Okay. Test this at 5% level of significance. Test at 5% level of significance. Okay. So now we will test for population correlation coefficient. Before we have test for mean when sigma square known or unknown, and for variance when mean is known or unknown. Then we will test for proportion. Okay, now we will test for the correlation coefficients. Okay, and here it is given. We need to test the populations are uncorrelated. So first we need to frame our hypothesis. So H naught populations are uncorrelated. That means the population correlation coefficient rho is equal to 0 against it is not equal to 0 because nothing is given like positive or negative correlate. So it is either 0 or it is not 0. Okay, so this is our hypothesis. What are the samples we are given? Like here n equal to 27 and R is sample correlation coefficient. Okay, and this value 0.42 is calculated with the help of these value, no? 27 pairs of observations. So that means it is a sample correlation coefficient, which is 0.42. Okay, we are given these two. Now, for the next step is define test statistic. We need to remember the test statistics under different scenarios. Okay, so all the other steps are like similar. So here, like in this case, the test statistics defined like R upon under root of 1 minus r square and n minus 2. Okay, so this is our test statistic. Now we need to calculate the value of t or the test statistic, which is equal to r equal to like 0.42 1 minus 0.42 square multiplied by 27 is there. So it is 27 minus 2. So it is 0.42 and it comes out to be like 0.8236 into it is root 25, which is 5. Okay. So, okay, let me solve this one more step. Upon the denominator term is 0.9, approximate value of this is this. So it comes out to be 2.1 upon 0.91 something. So the calculated value of t is 2.31. Okay. So we have calculated the test statistic this. Okay. Now the tabulated value t at n minus 2 degree of freedom and again not equal to case. So two-tailed. So it is alpha by 2, which is equal to now n equal to 27. So it is 25 and it is 0. Alpha is 5% level of significance. So that means 0.025. This value is like taken from the table and it equals like 2.06. Okay, from T table at 25 degree of freedom at 0.025 column, we have get 2.06 as tabulated value. Now again 2.31, which is equal to T, is greater than the tabulated value at 25, 0.025. That means what? Calculated value is greater. Calculated value is greater. This implies we reject the null hypothesis. That means our null hypothesis is this, and we reject it. This implies we accept it. Okay, so that means there are correlations. So we conclude that there are populations are uncorrelated. Okay, so there are correlation exist. Okay, so this is our conclusion. Okay, now next question is this question number 3. Okay. Next question is like for two independent sample, the following values are given. Following values are given. Okay, they are given sample size and like for first group, for second group, we are given sample sizes and sum of square of deviation about mean. Okay, sum of square of deviation about mean. Okay, so the data are like n1 which is equal to 8 and n2 which is equal to 7, and suppose for x variable it is summation of xi minus about mean, that is x bar, square term is also there, so it is 33.5. And similarly it's yj minus y bar whole square, it is 23.7143. Our question is, do the estimate of population variance differ at alpha equal to 0.05? Okay, so our question is this. Now we need to test what? Population variance. We need to test for population variance. Okay, and when the mean value is not given. Okay, also since there is no any specification that are equal or not something, so in that case first the hypothesis is defined like this. So in neutral nature we will define sigma 1 square is equal to sigma 2 square against the alternative hypothesis, which is not equal to sigma 2 square, because nothing is specified here whether it is greater than or less than, so it is not equal to. Okay, now our test statistic. Test statistic is we are testing for two means, two variances. Sorry, two variances. For this, S is defined, which is S1 square is S2 square. Okay, now the S1 1 upon N1 minus 1 xi minus x whole square I from 1 to N1. Here N1 is given 8. So 8 minus 1 is 7 into summation is this 33.5. Okay. So this comes out to be like
Excuse me, sir.
yeah.
Sir, ये s square is 1 by n minus 1. Why not take 1 by n?
We take the unbiased estimate now, because this is a unbiased estimate of sigma square. S square, which is 1 upon n S square, which is 1 by n summation of xi minus x bar whole square. It is actually biased for sigma square. Okay, so we use this. This is actually unbiased estimate of sigma square, and when we are not known the value of sigma square, then we test like this. We use that statistic, which is like good statistic for the particular population parameter.
Okay, sir. Thank you.
Okay. Okay. So that means it comes out to be around 754 point. Okay, it is 4.786 after calculation. We got this value. Similarly, ST square is calculated 1 upon N2 minus 1. summation j from 1 to n to yj minus y bar whole square, that is n2 equal to 7, 7 minus 1 6, and it is 23.7143. 23.7143. So it is approximate value is 4. So it is 3.952. Okay. So like these two are calculated. Also, you may know that here S1 square is greater than S2 square. So here it's also we have found 4 and 3. So the statistic F is 4.786 upon 3.952, which after calculation comes out to be 1.2117. Okay, so we have calculated the test statistic. Now the tabulated value. So F value at n1 minus 1, n2 minus 1 at 0. Okay, at alpha by 2 is F. N1 minus 1 is 8 minus 7 and 6. Okay. 7 and 6 and 0.025. This value is taken from F table, and F table have 2 degree of freedom. Okay. One is in row, in column. So 7, 6, we get the value of this is 5.69. Okay. So again, here the F value is less than F at 760.025. So calculated is less, tabulated is greater. So this implies we fail to reject the null hypothesis. That means what? We fail to reject the null hypothesis. That is, we accept the null hypothesis. Okay, that means sigma 1 square is equal to sigma 2 square. This implies the population differ at this. So no, there is no difference. So our result is, so we may conclude the data, or sorry, the sample are drawn from population having same variance. Okay, so we conclude that the data drawn from the population will have the same variance. Okay, okay, so this is it, I think. Wait, I have some more questions. There is one question.
एक्चुअली सर एक बार स्क्रीन को पीछे करेंगे सर, प्रीवियस 1 मिनट सर.
Yes.
सर ये कैलकुलेटेड वैल्यू तो लेस है टेबुलेटेड वैल्यू जो वैल्यू से, तो ये क्या रिजेक्ट हो जाएगा सर?
Wait. I will show you one more PDF. Actually, in yesterday class, we have seen various cases when we accept or when we reject the hypothesis. Okay. So in this scenario, when like calculated value is less tabulated, then we accept or we fail to reject the null hypothesis. Okay. So here it is clearly mentioned.
Yes, sir. Sorry, sir. Okay, sir.
Okay. Actually, let me show you one thing actually. Yesterday's. Okay. Like in yesterday class, we have discussed about these things, test for normal population. Okay. So there are different scenarios when this type of hypothesis is assigned, defined in 3 different ways. When greater than case, less than case, greater than case, or equal to case. Under different scenarios, different types of conclusion on the basis of the calculated and tabulated values are drawn. Okay, so all are already discussed by Sumesh sir also. Okay, and this particular PDF is also available to all of you. Hope if you don't have, then I will mail or provide you by any way. Okay. Next question is
Thank you,
like,
sir.
okay. The next question is like, there's one more question actually. Okay. A certain test is conducted. A certain test is conducted on 12 patients, which represents the change in BP. Change in blood pressure, BP. The data are given. Okay, I will write in tabular form later. And we need to, can it conclude that a certain test will, in general, be accompanied by an increase in BP? Okay, so we need to test, can it conclude? Can it conclude that a certain test will, in general, accompanied by an increase in BP at 5% level of significance? Okay, so similar question again. We first define what are given in the question, then we define hypothesis, then the test statistics is calculated, and then tabulated value, and at last conclusion. Okay, so here we are given n equal to, okay, we are also given a data actually. Let me write the data as well. Okay. So let me first define the hypothesis in this page. Okay, hypothesis is like, let me write D. I will define what is D. So that is increase in BP. Okay, so the neutral nature is like either D, which is increase in BP. Okay, so it is either increase or not increase. Okay, so 0, which is not increase, or increase, this means 0. This is the difference. Difference of what? The previous data and the BP in after like applying some other like what? Wait. It can conclude that patient represents change in BP. Okay, certain test is there, na? Okay, so at first test and at second test, the increase in BP is like observed or not. So this is the increase in BP. So D equal to either 0 or D is greater than 0. Now the data is like this. Okay, data is okay. Now the difference is given di, which is the difference in the previous and the new test, which is like 5 to 8. Okay, just look it. It's 8, no? Yes. 5 to 8 and then minus 1. 3, 0, minus 2. 3, 0, minus 2. 1, 5, 0, 4, 6. These are the data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we are given 12 patients. So we are 12 data. Now, the next step is test statistic. So in this case, this is like pair test. Okay, this is a pair test. So in this scenario, the statistic is the test statistic is like this. T, which is equal to root and d bar, the difference, mean of the difference, and SD, sample variance of difference. Okay, so this is, so that means we need to calculate d bar. After summing di, we got it at 31. Okay, so d bar equal to 1 upon n summation of di, simple, 1 upon 12 into 31. So it comes out to be 2.558. Okay, 2.58. Okay, now we need to calculate SD. So SD square again, 1 upon n minus 1 summation of di minus d bar whole square. So we need to calculate di minus d bar whole square. So it is 2.58 and di 5 minus 2.58. So this comes out to be like 2.42. Let me write it quickly. Minus 0.58, 5.42 minus 3.4, 3.58, sorry. 3.58, 0.42 minus 2.58 minus 4.58 minus 1.58, 2.42 minus 2.58 minus 1.42 and 3.42. And the square term will be like the whole square is 5.8564. This is 0.3364. It is 29.3764. It is 12.8164. 0.7164. 6.6564. Okay, 20.9764. 2.4964. 5.8564. 6.6564 and 2.0164, and the last one is 11.6964. Okay, so after summing, we get the summation is 104.9168. Okay, these are just calculation. Okay, so 1 upon 12, not 12, it's 11, and it is 104.9168, which comes out to be, after calculation, it comes out to be 9.5379. Okay, now the next step is to calculate the test statistic t, which is root n equal to here 12 into d bar equal to 2.58 and SD is 9.5375. Again, with the help of calculator, we will find out, like it is 8.94 divided by 3.09, which approximately equal to 2.98. Okay, so t value, the calculated t is this. Now the tabulated t, Okay, so the tabulated T at n-1 degree of freedom, and here, like here, see, here alpha is this single tail, one tail. So directly we use alpha. So that implies this value at 12 minus 1, 11 and 0.05 in with the help of T table, it comes out to be 1.796. Okay. So here, okay, sorry. Here T value is greater than tabulated value. Okay. The calculated value is greater than the tabulated value, 11, 0.05. So calculated is greater, we reject the null hypothesis. That is, we reject the null hypothesis. That means what? Okay, we reject the null hypothesis. That means this is rejected. That is, this is correct. Okay, so the difference is not zero. That means the difference is greater than zero. So can it conclude that a certain test will generally be accompanied by increase in BP? So yes, it increase. Okay, so that means the effective in increasing in BP. The test is like contributed to increasing BP. Okay, so this is how like we use the testing under different distributions. Actually, under normal distribution, most of the cases we will discuss. Okay, now there are some more questions like related to NP lemma and something. There are 2 or 3 questions are there. Let me complete it as well. Okay. So this is from testing of hypothesis. Okay. And the above one is also from testing of hypothesis. The question is like, let x1, x2, x3, sorry, and x4 be a random sample of size alpha. Sorry, of size 4. No? There are 4, not alpha. From normal population with mean mu and variance 2 square. That is 4. Okay, to test H naught such that mu equal to 0 against H1 such that mu equal to 1. The critical region is defined like this: X bar, which is greater than 0. Critical region is also called region of rejection actually. Okay. Then find the size of the test. So size of the test, that means alpha value. Okay. So again, like we are given xi follows normal mu sigma square if then x bar follows normal x bar follows mu sigma square by n. So this implies here xi follows normal mu and 2 square. This implies x bar follows normal mu 2 square upon I are given here 4 actually 2 square upon 4. So x bar follows normal distribution with mean mu and variance it is 4 actually. Variance 1. Okay, so it is given. Now the rest is simple. The hypothesis is given like this: h naught mu equal to 0 versus h1 mu equal to 1. Okay. And the critical region W is x bar, which is greater than 0. So these are given. Now we need to calculate the size of the test, that is alpha. So alpha will be like probability. The definition is reject H naught when H naught is true. This is the definition of the alpha. Okay. So reject H naught. H naught is rejected when it lies in the critical region or region of rejection. This is also called region of rejection or critical region. That is a possible region of rejection. Okay. So reject H naught when H naught is rejected when X bar is greater than 0, then H naught is rejected under H naught is true. When H naught is true, mu equal to 0. Simple. Okay. So mu equal to 0, H naught is this. So that means we need to calculate the probability of this. X bar is greater than 0. Okay. So it is since it is a normal distribution, and you people know when we are dealing with the normal distribution, we just transform it in a standard normal variant. So that means what? X bar minus mu upon sigma. The sigma is here 1. So let me write 1 here directly. Is greater than 0 minus mu upon 1. Okay. At mu equal to 0. At mu equal to 0. So let me write the mu equal to 0 as well here. Okay. We need to calculate this. X. Actually, I use this. Na? If X follows normal mu sigma square, then Z, which is defined as X minus mu upon sigma, this follows normal 0, 1, and then the probability is calculated with the help of normal table. So in a similar way, X bar minus mu upon the standard deviation 1 is greater than 0 minus mu is 0 upon 1. This mu is 1 is there. So that means what? That means, okay, sorry. So that means probability that Z is greater than 0. Again, we know that the curve of the normal distribution is symmetrical about, and we are discussing about the standard normal. So it is Z equal to 0. So this area is 0.5. This area is 0.5. So probability that Z is greater than 0. This means this area. And this is nothing but 0.5. So the value of alpha or the size of the test is 0.5. Okay. So similar questions are there. There are many questions actually. There is one more question I'd like to solve. If a very simple question, but okay, let me solve this. The last one. The question is like let x1, x2, f2, xn be a random sample from a uniform distribution. Be a random sample from a uniform distribution with parameter 0 and theta. Okay. For testing h naught such that theta equal to 1 against h1 such that theta equal to 2. Critical region is defined as the critical region CR is defined like this, which is equal to maximum of I from 1 to up to n, maximum of xi, x1, x2 up to xn, maximum of xi. Okay, is greater. Okay, sorry. xi is greater than 0.5. Okay, so maximum of this is greater than 0.5. This is our critical reason. Now we need to calculate probability C under H naught, probability C under H1. Okay, we need to calculate this. Can anyone tell me what is this? Which quantity is this and this? Just by the definition, try to. C is our critical reason, H naught is true. C is our critical reason, H1 is true.
But the first term is
Hello.
as of hello. Hello.
Hello. Yes, yes.
The first term is probability of type first error, and second is the power of the test.
Okay. Correct. Yes, this is right. Because the first one is what? C under H naught. This is C means critical reason. That is reject H naught. When H naught is true. This is nothing but alpha. And the second one is what? C under H1. That is C. That is reject H naught again. When H1 is true. This is the power of the test. So we need to calculate alpha and 1 plus beta. So either you calculate alpha and beta and then 1 minus beta is calculated and then solve, or you may solve it directly. But one thing that I want to focus is that here this, we are discussing about this maximum of xi. So we need to find the distribution of maximum of xi there. Na? Because the probability term is involved, like here, probability of this. So probability of this is this and normal. So we calculate with the help of standard normal curve. But here, uniform. We need to calculate the probability. So first is like since xi follow uniform 0 theta. So our fx is what? 1 by theta when x lies between 0 to theta, and capital X, which is the CDF. CDF is x by theta. Okay, now the distribution of f of xn, that is max function of maximum of xi. We need to calculate the distribution of this, and we know the formula for this is like n fxn power n minus 1 and fx. So n is here n because we are not given the value of n. I from 1 to n is there. Okay, fxn is x upon theta power n minus 1 and small fx is 1 by theta. So after simplification, we get n upon theta to the power n, x to the power n minus 1. Again, like x lies between 0 to theta. So this is our PDF. Okay, now the rest thing is as usual. Okay, let me solve it quickly. So our hypothesis will be like theta equal to 1 against theta equal to 2. Okay, and the given critical reason will be like maximum of xi is greater than 0.5. Okay, so maximum of xi can also be written as like xn. So this. So acceptance reason will be like less than 0.5. You may write equal to either here or here on your convenience because it is a continuous distribution and the probability at a point is 0 at continuous distribution. Now we need to calculate that probability of, actually it is C. In question it is C. Na? So C under H0 plus probability that C under H1. We need to calculate this. So this implies, just step by step, reject H0 when H0 true, plus like reject H0 when H1 is true. Okay. So reject H0. That means when H0 lies in critical region. Okay. This Xn is greater than. So that means what? Xn greater than 0.5 under H0 theta equal to 1. Theta equal to 1. Okay. Plus probability that Xn greater than 0.5 under theta equal to 2. Only we need to calculate this probability, nothing else. So Xn, the PDF of Xn is greater than 0.52 theta. So it is 0.52 theta. Xn is now this. This is our Xn, the PDF of Xn actually. N theta power n, x power n plus 1. N upon theta power n, x to the power n minus 1 actually, dx. At theta equal to 1 plus in a similar manner 0.52 theta n upon theta to the power n x to the power n minus 1 dx at theta equal to 2. The rest is theta equal to 1 is put. So 0.5 to 1. N is taken out common, theta to the power n equal to 1. So x to the power n minus 1 dx plus theta equal to 2. So n upon 2 to the power n 0.522 x to the power n minus 1 dx. Now n x to the power n upon n 0.521 plus n upon 2 to the power n x to the power n upon 0.522. So n will be cancelled out. So 1 minus 0.5 to the power n plus here. Okay, n upon 2 to the power n is there. So n will be cancelled out here also. So 1 upon 2 to the power n. So 2 to the power n minus 0.5 to the power n. So 1 minus 0.5 to the power n plus 1 minus 0.5 to the power n upon 2 to the power n. Okay. So it is 2 minus 0.5 to the power n will be taken as common. So it comes up to be 1 plus 1 upon 2 to the power n. You may solve this or you may like, so this is our answer. Actually, this is our answer. This is nothing but the probability that C under H0 plus probability that C under H1. Okay, you may solve this, or when we are given the value of n, we may exactly give the numeric value as well. So these are type of questions related to testing of hypothesis. Okay, so if anyone have any doubt, he or she may ask. Okay, because this is the last class, and after that, you people have enrolled for exam or not? Anyone?
Yes, sir.
Okay, okay, and you know when the exam will be held?
I think 28th of April.
Yes, I think it is 28th of April, and the examination is based on like computer-based exam is there. Okay, so like there are fill in the blanks type of question and CQs type question, and there are some question in which you have to type some answer. Okay, like maybe some definitions or some properties or some interpretation of any kind of statistic. So please be ready for that. You are also allowed to ask question to me. Let me share my number. Okay. So let me, the number is like my WhatsApp number is like this. My email address is like CHANDAN underscore triple two one MA02 at the rate iitp.ac.in. Okay. And my WhatsApp number will be like plus 8 931 931 731. Okay. By any means, you may contact me if you have any doubt regarding the course questions or if you want to ask anything. You're all welcome. Okay. So if you don't have any question, then I think we should conclude here. All the very best for the examination. Okay. Yes.
Yeah, sir, this recordings can be provided or this sessions recorded doubt sessions. Like I've missed 3 of the sessions.
Yes. Yes. The recording. I think you all got the link in like weekly log sheets are there. Na? You people got the weekly log sheet and there all the links are available. Even all the 3 tutors links are available there. There are 2 more tutors there in this particular course, and we are all independently teach these things. Okay, so everything is there. If not, either mail or message me. I will provide the link. Okay.
Sure. Yeah, thank you. Sir, and one more thing, the last concept question you have explained, right? The previous one. Yeah, this one, like 1 minus 0.5. So this concept, I'm not that much clear. So which one I need to refer, like this concept?
Okay, this is from actually week 11's lecture. This is testing of hypothesis, the first lecture, which is 11th lecture actually. Okay, there we will discuss about the what is alpha and beta, how to calculate the type 1 error, how to calculate type 2 error, and the power of the test also is there. Okay, most powerful test is calculated with the help of Neyman-Pearson lemma. Okay, so you may see the week 11 lecture. So you will got the numericals on these types. It is very simple actually. Okay, like let me. Okay, if you have a time, let me just tell you one thing. Like this is the question. We are given a sample. We are given a sample. Okay, of some size. We need to test this hypothesis. So we need to do what? First thing, we need to frame the hypothesis. These are the above are the given thing. Okay, these are already given in questions. Okay, first we frame the hypothesis, then we find the critical reason. The critical reason is this, and the critical reason is called the region of rejection. Okay, so our alpha is defined as reject H naught when H naught is true. H naught is rejected when the X lies within the critical reason. That means X lies within the this. So this means probability that X is this under H naught is true. So under H naught, the mu is 0 and under H1, the mu is 1. So under H naught, the mu is 0. So now we put the values and solve. Just simple probability. Our aim is to just frame these things.
Okay. Okay, to get the equation, our aim is to get the equation. So when n value will be given, we'll be testing on that.
Yes. Okay. And the most like we have discussed many questions in week 11's lecture. So I will provide the lectures link. Okay. Even my YouTube link is also there. If you follow this link, now you will get all the things actually. No need to. These are my YouTube links. It's capital NPTEL dot small statistics. Okay. The name of the channel is Chandan Kumar Gupta. My full name is there. Okay. So you will got there the whole lecture. There is a playlist of probability and statistics where you will got all the 13 lectures. There are 12 lectures are there. I will upload the 2 today. Okay.
But yeah.
Okay. Anyone have any other doubts? If not, then
No, sir.
I think okay. Then I think we should conclude here. Let me first stop the recording then.